Hi, this is time for Physical Sciences. This is Tinyiko Kosa, better known as TK. And today we're looking at lesson number 21 and we're talking about electrostatics, okay? And what is this thing here? And like we always say, 10 to 12, you are both catered for, so don't go anywhere. This Physical Sciences is for the whole FET. All right, now, electrostatics. Electrostatics has got something to do with charge. And what about charge? Electrostatics is the study of charges at rest. In other words, we're looking at charges that are not moving, charges that are stationary, charges that are not moving. That is what electrostatics is all about. So we study their behavior. We study how they interact with each other, what they create around themselves. That's what electrostatics is about. When a plastic comb is rubbed against a cloth or hair, it is able to pick up pieces of paper. Perhaps I should have done this for you. I should have brought a piece of comb here and then have pieces of paper so that you can see. But I think most of you know what I'm talking about, because this is one experiment that people or learners right from the lower grades, primary, okay, are doing it. They're playing with the comb on their hair and then have pieces of paper. They pick those up by using that comb. Now, what is happening there? What has happened for that piece of plastic comb to be able to pick up the small pieces of paper? Right now, what has happened to this plastic comb? Now, the plastic comb attained a charge when it was rubbed against the cloth or hair. And it is that charge that makes it possible for the comb to pick up these small pieces of paper, okay? When certain objects are rubbed against each other, they either transfer or gain electrons, okay? Before an object gains or transfers electrons, it has equal number of positive and negative charges. And we therefore call it a neutral object. Before an object gains or transfers electrons, like I said, it is neutral. Now, when it gains electrons, it will have an excess of negatively charged particles because electrons are negatively charged. And at that point, we'll say the object is negatively charged. Now, let's have a look at what happens when it has transferred its electrons instead of gaining them. When it has transferred these electrons, which are carrying the negative charge, it will mean that that object now has an excess of positively charged particles. And remember, the positively charged particles are what we call protons, okay? And therefore, at that point, we'll say that this object is positively charged. There are two types of charge as we know it. We've got positive and negative charges. The positive charges are carried by particles called protons, and the negative charges are carried by particles called electrons. The positive particles are protons, as I've said, and negative particles are called electrons. Protons are not free to move, whilst electrons are free to do so. A force will always exist between charged objects. Like charges repel each other, so the force of repulsion, and unlike charges would attract each other. Positive, negative attract, positive, positive repel, or negative, negative, right? Now, charge is quantized. What we mean by this? It can only carry or have a value that is a multiple of a particular charge, which is the charge on an electron. Now, what is the charge on an electron? The charge on one electron is 1.6 by 10 to the power minus 19 coulombs. Okay, now it means if you acquire one electron, you have acquired that amount of charge. If you acquire 2 electrons, it means you have acquired twice that charge there. You cannot have half of this or a quarter of this. It is quantized. It is a package. That is what the charge is about. And the unit of measurement of charge is what we call the coulomb, and we abbreviate it as C. Okay? The unit of measurement, like I said, is the coulomb. We abbreviate it that way. An oxygen atom with 8 protons and 6 electrons would be obviously positively charged because it has got less electrons than protons. Okay? And we can calculate the charge there. Let's meet in the next section.